My name is Brandon, and I'm with the City of Dayton Water Supply and Treatment Division, part of the Water Department. I am the Water Treatment Technical Supervisor, and what that means is that I'm in charge of water quality, over the laboratory, and any EPA compliance.
Yeah, my name is Emily. I'm a water instrumentation specialist here in the lab. So a little bit of what I do is I look at metals, inorganics, things like nitrate, nitrites, volatile organic compounds, and check things like bacteria in the water.
Today we're going to talk about and show you the water treatment process. The City of Dayton adds calcium oxide to the water, which is a process called coagulation, flocculation, sedimentation, and filtration. Coagulation is the chemical addition to the water. Flocculation is the particles binding together, becoming heavier than water. Sedimentation is the particles falling out of solution, and filtration, which is those particles being filtered out. This is the upflow clarifier. This represents, what you're seeing now represents the coagulation, flocculation, sedimentation step. In this inner basin, that's where the coagulation and flocculation happens, and in the outer basin is the sedimentation. This is the outer basin where the sedimentation happens. You can't really see much from here, but the particles are clinging together, falling to the bottom, and the clean water is going through these troughs and out to the filter gallery. What you're seeing now is a sand filter. This happens after the coagulation, flocculation, and sedimentation step. The water comes in and is filtered by layers of sand and gravel for that kind of final polish to make the water really clear and clean.
Okay, so we are going to simulate what happens in the water treatment process. So as you can see, this is dirty water replicating what would come in from our well field.
Who would drink this water? Nobody. You
No.
Put your hand
There's
down.
always one
You
kid.
wouldn't drink this.
There's
You would
always
not
one.
drink this.
Yes, so hopefully nobody would drink this. So what we're going to do is Procter & Gamble actually makes a packet that kind of simulates what we do across the street. So what I'm going to do is I'm going to add this packet. It contains calcium hypochlorite, and what we're going to do is then stir for 5 minutes. So adding this packet right now acts as the coagulation process, right? It's the addition of a chemical. And then the stirring is going to represent the flocculation, which is where you are agitating the particles. And then eventually they're going to keep bumping into each other, and then they'll stick and get heavier and heavier and heavier. And then when I stop stirring after 5 minutes, they're going to fall out of solution, and you guys will hopefully be able to see this clear up, and then we're going to filter it.
Procter & Gamble actually developed this packet as part of their laundry division on accident. They were trying to just get a lot of dirt out of laundry, and they realized that this had water quality properties. And they actually sell this to areas that don't have access to clean water, and it can create up to 50 gallons, 10 liters of water.
Yeah.
Clean, drinkable water. So for areas either that don't have access to water or temporarily you don't have access to water, you can use this packet to make clean, drinkable water.
And that's really cool. I think one of the things we take for granted a lot is that we have access to clean water. So a lot of times you guys probably just go to the water fountain or you turn the sink on at home and clean water comes out and you guys don't have to think about it. So that's something we maybe take for granted, is that we have clean, safe drinking water available to us at all times.
Another thing this packet does is it disinfects, which means it adds a chemical that kills any bacteria. And how we test for disinfection is we have a chlorine test here. And as you can see, it turns pink. And you use the meter here, and you just click the read button, and it tells you how much chlorine is in the water. 1.27.
Okay, so it's been 5 minutes of stirring. So what I'm going to do now is I'm going to stop stirring or flocculating. And what you guys are going to see, hopefully, is that all the sediment is going to settle out. And again, this is what happens on a small scale in our basins at the water treatment facility. So those particles that were bumping into each other started to stick together and got heavier and heavier, and now they've fallen out of solution. So the final step in the process is filtration. So we use sand filters in our treatment process. However, for today's purpose, we're going to use a cloth. So As you can see, we still have some floaties, right? So even after sedimentation, you'll still have some floaties in the water. So what we're going to do is slowly pour this through the filter, and this is going to get any floating debris out of the water. So it acts as a strainer. Okay, let me show you. So now, outside of the string, we have clean, drinkable water. How many of you guys would drink it now? Yes, hopefully everybody, because this is now safe, clean drinking water. So this on a small scale is what we do across the street in our water treatment process.
And now a behind the scenes look at what our water instrumentation specialists and bacteriologist chemists do day in and day out here at the Water Quality Lab to make sure that you have safe drinking water.
Well, that's all we have for you today. Thank you for giving us a chance to speak about water quality and water treatment process, and thank you for attending the Children's Water Festival. Hopefully it was informative and entertaining.